Right now, somewhere in the world, there is a highly paid, brilliant software engineer who is absolutely not writing code.
Oh, definitely not.
No, they are sitting in, what, their third Zoom meeting of the day?
Probably their fourth,
No,
honestly.
their fourth meeting. And they are basically acting as a human translator, between the billing department's software and the video player's software.
Just trying to figure out why the two systems decided to stop talking to each other at like 3 in the morning.
Exactly, at 3 a.m. And they're exhausted. They are incredibly frustrated. And they are spending all of their creative energy just trying to keep the machines from completely falling apart.
Yeah, it's the absolute definition of diagnostic muddy waters.
Muddy waters, I like that.
Because we build these incredibly complex digital structures, right? Supposedly to do our work for us. But increasingly, we are spending all our time just maintaining the structures themselves.
Yeah.
And if you talk to people in the trenches of software engineering or, honestly, even organizational design, there is this pervasive, quiet burnout. Like the systems we rely on are billing us this massive emotional and technical tax every single month.
Welcome to the deep dive. Today, our mission is to explore a radical, highly pragmatic, and slightly delicious new concept in systems design.
Very delicious.
It was built specifically to solve that exact burnout. It's called Baumkuchen Architecture.
Which is quite a name.
It really is. And this framework was developed by two thinkers, Michaela and Beautify, at a company called Vanoras. And I have to say, the stack of sources we are pulling from today is, well, it's not your standard dry academic tech reading.
Not at all. I mean, we're looking at a very raw working document.
Yeah.
There's a long-form architectural design essay, a formal press release, and honestly, my favorite part, these highly entertaining interview transcripts.
They read almost like a tech philosophy stand-up routine sometimes.
They really do, because they aren't just handing us a sterile blueprint. They are actively documenting the psychological friction and the organizational chaos that made this theory absolutely necessary in the first place.
Right. And I want to speak directly to you, the listener, for a second here. Because whether you are a software engineer deep in the Kubernetes configurations or, an organizational leader trying to map out why your company's departments refuse to collaborate,
Which happens everywhere.
everywhere. Or even if you're just someone fascinated by the friction between human beings and the systems they inhabit, this deep dive is for you. Because fundamentally, the Vanoras texts are arguing that the structures we build dictate how we behave.
Exactly. How we communicate.
Right, and ultimately whether we will ever be able to genuinely partner with artificial intelligence.
Yeah, to really grasp the weight of what Michaela and Beautify are proposing, we need to rewind the tape a bit.
Oh.
We have to set the stage by looking at the evolution of modern digital infrastructure. Because Baumkuchen architecture doesn't just exist in a vacuum. It's a direct reaction to a very specific historical shift.
Right.
For a long, long time, the absolute industry standard for building software was the monolith.
Okay, let's unpack this, because when we say monolith, for anyone listening who isn't, writing code every day, what does that actually look like in practice?
So imagine a massive single block of code where absolutely everything is deeply intertwined.
Okay.
The database, the user interface, the payment processing, the security protocols, they are all woven together in one giant application.
Got it.
If we use a restaurant analogy, a monolith is a single gigantic kitchen.
I'm picturing chaos already.
Oh, it is. The chefs, the dishwashers, the waiters, the managers, they're all standing shoulder to shoulder using the exact same ingredients from the exact same massive fridge.
So if someone drops a pot of soup, the entire kitchen basically slips and falls?
That is precisely the vulnerability. In a monolith, if you want to change one tiny feature, say, you just want to update the font color on the checkout button.
Just a basic aesthetic change.
Right. You have to deploy the entire massive application all over again. And if a bug in the billing code causes a memory leak, it crashes the video streaming code too.
Because they share the same environment.
Exactly. So as companies grew, these monoliths became really heavy. They became rigid and honestly terrifying to update.
Terrifying because you might break everything all at once.
Exactly.
So to solve that exact problem, the tech industry executed a massive pivot. And this is where the giants come in, right? Companies like Netflix and Amazon popularized a complete shift away from that giant kitchen. They moved toward microservices.
Yes. They took that giant undifferentiated block and shattered it.
Shattered it into hundreds or thousands of pieces.
Sometimes thousands, yeah. Thousands of tiny independent services.
Wow.
Returning to our restaurant analogy, the microservices architecture is like a massive food court.
Okay, I can visualize that.
You have one stall that only chops the carrots, another stall that only boils water, another stall that only handles taking the customer's money.
But wait, they all have to talk to each other constantly to produce a single bowl of soup for the customer, right?
Exactly. They communicate over a network, usually through APIs. And look, initially, this was a total revolution.
Because it solved the bottleneck.
It solved the scaling issues of the monolith beautifully. It gave massive teams deployment independence. Like, the carrot chopping team could update their tools at 2 p.m. without having to ask the water boiling team for permission.
Right, which allowed for massive, rapid, decentralized growth.
Huge growth.
So if microservices were the hero of the story, if this architecture literally saved Netflix and Amazon and allowed them to scale into these global behemoths, why on earth are the folks at Vanoras looking for an alternative?
Well, before we dive into the technical nuts and bolts of the new architecture, we have to look at how this Baumkuchen concept was actually born. Because the origin story itself completely challenges how we usually think about formal research.
Right, because there is definitely this myth in tech and in academia too that groundbreaking ideas only emerge from these highly formalized, sterile laboratory processes.
We always picture a rigid whiteboard session.
Right.
Like 20 senior engineers locked in a glass room mapping out node diagrams for weeks on end.
But the sources explicitly point out that the Baumkuchen concept didn't emerge from a whiteboard session at all.
No, it came from something they call the Vanoras working rhythm.
The working rhythm.
Mm.
And this is fascinating because it heavily leans on the psychology of how human beings actually solve complex problems.
The working document outlines this rhythm perfectly. It's this deliberate, multi-stage cycle. And it begins with intensive, targeted input gathering.
Which means reading, right?
Yeah. In this specific case, Michaela and Beautify were actively reviewing public case studies of AWS, Netflix, and Amazon.
So they were looking at the giants.
Exactly. They were looking at how these massive tech giants structured their microservices, looking at the cloud-native patterns, the scaling paths, the cost structures. They were just absorbing all of this heavy, dense material.
And then they do practical checking against their own existing structures at Vanoras.
Right.
But here's the crucial pivot. They don't force a conclusion right then and there. They step away.
They explicitly build in time to retreat into ordinary, non-technical work.
Which is so rare in corporate tech.
It's unheard of.
Yeah.
But they allow for an incubation period.
And as we know, that's neurologically sound, right?
Very much so. When you are intensely focused on a problem, your brain is using its executive control networks, which are great for analytical thinking, but they're actually terrible for lateral creative leaps.
You just get stuck in a loop.
Exactly. But by stepping away into mundane tasks, you allow the brain's default mode network to take over. It starts making background connections without your conscious effort.
It's that universal experience. Like, have you ever been in a heated conversation or a debate and you completely blank on a specific word?
All of the time.
You rack your brain, you stare at the ceiling, you actively try to force the word out, and you just can't find it. So you give up, you walk away, and then 3 hours later, you are standing at the kitchen sink washing a coffee mug, and boom, the word drops into your consciousness out of absolutely nowhere.
That is precisely the psychological mechanism at play in the Vanoras origin story.
Washing the dishes?
Literally. The texts note that the core architectural idea did not happen while Michaela was passively staring at white papers on cloud-native containerization. It happened afterward, during ordinary household activity. That is when what they term the structural click occurred.
The structural click. I love that phrasing.
It's great.
And that sudden synthesized click was the image of a pastry.
A Baumkuchen.
The mind had been processing all that heavy material, you know? The rigidity of the monolith, the chaotic fragmentation of microservices, the compounding costs of network latency.
All the problems. Right. The material incubated, and suddenly a physical metaphor became perfectly visible in her mind. A layered cake. It made complete structural sense to her in a way that traditional abstract architecture diagrams simply didn't.
What I find brilliant is how they chose to document this realization. The Vanoras working document itself is split into 3 distinct, separate layers, and the text specifically warns the reader not to confuse them.
They're very methodical about this. Layer A is documented as the idea trigger layer.
Okay, so what's in layer A?
This is the source trail. It's the raw inputs. The YouTube videos of tech talks,
Yeah.
the AWS architecture case studies, the blog posts about Netflix's engineering culture. This is what sparked the thought.
The raw ingredient.
Exactly. Then you have layer B.
Well.
Layer B is the original contribution layer. This is the Baumkuchen concept itself. the synthesizing of the problem into a new framework.
The cake itself.
The cake. And finally, layer C is the future research layer, which contains all the subsequent testing, the challenges, the stress testing of the metaphor against real code, and the refining that still needs to happen.
Which tells us right off the bat that this isn't some finished dogmatic doctrine that they are trying to force onto the entire tech industry.
No, not at all.
They aren't selling a one-size-fits-all software package. It's a living, adaptable design philosophy. It's a pragmatic first response to a massive, painful industry tension.
Which brings us back to the core tension itself. We know how the idea incubated at the kitchen sink, but what exactly was the underlying problem with Netflix and Amazon's approach that triggered this entire journey?
Right, why were they so frustrated?
Michaela and Beautify were trying to peer underneath what the essay calls the romance of modern tech architecture.
The romance of microservices, that word is so telling.
Isn't it?
The architectural design essay in our stack points out that tech culture has a massive tendency to create false binaries. Like, once a new development model becomes fashionable, the industry acts like there are only two moral choices left in the world.
Very true.
The essay says we frame monoliths entirely as old, rigid, heavy, and obsolete, while microservices are framed as modern, scalable, elegant, and necessary. It essentially becomes a cult of the microservice.
It absolutely does become a cult. I mean, if you go to any tech conference over the last 5 years, if you aren't talking about how you've decomposed your app into 300 microservices, you were viewed as a dinosaur.
Right, you're living in the Stone Age.
But we have to be analytical here, and the Vanoras sources are very careful to be fair to the history. The move toward microservices wasn't born out of stupidity.
No, it solved real problems.
Exactly.
Yeah.
Large companies decompose their services for very legitimate, pressing reasons. It solves real growth bottlenecks.
Well, let me play devil's advocate here for a second. Because if you're listening to this and you've spent the last 3 years of your life migrating your company to microservices, you might be feeling a bit defensive right now.
Oh, absolutely. It's a massive effort.
Right. So if microservices gave Netflix the deployment independence they needed to become a global superpower, isn't specialization fundamentally a good thing? Like, we want things to be modular, right? We want the billing team to operate independently from the video streaming team.
This raises an important question, and it cuts to the exact core thesis of the Vanoras critique. The problem they identified in those AWS and Netflix case studies is not specialization.
Okay.
Specialization is highly effective. Modular code is good. The actual problem is uncontrolled fragmentation.
I need to understand the difference between specialization and uncontrolled fragmentation. Where is the line? Because they sound very similar.
Think back to our food court analogy. Specialization is having a dedicated stall for boiling water and a dedicated stall for chopping carrots. That works great if they are making entirely separate meals. But in software, they are usually contributing to the same user experience. When you shatter a system into 1,000 tiny, isolated microservices, those services still have to talk to each other over a network to get anything done.
Right. They have to coordinate.
And that network communication is where the hidden tax comes in.
The language they use in the interview transcripts to describe this tax is incredibly evocative. Beautify mentions that when specialization turns into fragmentation, it starts billing you every month.
Yes.
And they make it clear they don't just mean financially on your AWS server bill, though, I mean, that definitely goes up too.
Skyrockets.
But they mean technically, and quite profoundly, they mean emotionally.
Let's break down the technical hidden costs first, because they're measurable. The sources point to 4 major culprits here: too many service boundaries, endless crossings, thick dependency chains, and entirely too many access points.
Okay, give me an example.
Let's say a user opens an app and wants to see their profile. Just a basic profile page.
Simple enough.
Right. But in a highly fragmented system, the front-end service has to cross a boundary to ask the user ID service for authentication.
Okay.
Then it crosses another boundary to ask the image service for the avatar picture.
Right.
Then it crosses another boundary to ask the preferences service for, say, the dark mode settings.
So every single time it crosses a boundary, it's asking a cron over a network.
Precisely. And every single network hop introduces risk. The texts call this latency risk and mismatch risk.
Latency risk, I assume, is just things being slow.
Latency risk is simple, yeah. If the image service is running slow or the network just has a tiny hiccup, the entire profile page hangs. The user is just staring at a spinning wheel because one tiny service out of 50 is having a bad millisecond.
Oh, wow. And mismatch risk, what is that?
Mismatch risk happens when these independent teams get, well, too independent.
Ah.
Say the user ID team updates the format of their data. They decide to change the ID from a number to a string of text, but they forget to tell the preferences team. Exactly. The moment the preferences team asks for the data, the system throws an error and crashes. You have a mismatch.
So to prevent that from happening, teams have to build massive amounts of duplicated infrastructure logic. They build fail-safes, retry mechanisms, circuit breakers, complex API gateways, all just to manage the conversation between their own internal tools.
Yes. And suddenly, you reach a tipping point. The architecture stops serving the primary business goal. It flips. It starts demanding to be served by the engineers.
The architecture starts maintaining itself instead of doing useful work.
Exactly.
That is such a clarifying realization. I think so many people listening can relate to this. You build this incredibly complex machine to solve your users' problems, and within a few years, 80% of your engineering energy goes into just keeping the machine from breaking apart under its own weight.
You're paying rent to your own complexity.
Paying rent to your own complexity, and that is the exact agonizing tension that drove Michaela to the kitchen sink in the first place.
Right. If the monolith is a giant, shapeless block that is too rigid to update, and microservices are 1,000 tiny, isolated islands that require constant, exhausting translation and network maintenance. What is the structural middle ground?
Which brings us to the pastry.
The pastry.
I think we finally have the context to understand why this metaphor works. I present to you the Baumkuchen.
It really is a phenomenal visual aid. Because in software architecture, we rely so heavily on abstract boxes and arrows that we often lose sight of the physical flow of logic.
Yeah, in the interview transcript, the interviewer actually asks her directly, why cake? And Michaela gives this brilliant, totally dead-on answer. She says, because for once, the cake explains the architecture better than the architecture diagrams explain themselves.
I love that quote. And to fully grasp the utility of the metaphor, we should probably explain what a Baumkuchen physically is for those who haven't had one.
Good idea.
It's a traditional European spit cake, very popular in Germany and Japan. When you bake it, you brush a thin layer of batter onto a rotating spit, let it brown, and then brush on another layer.
Layer by layer.
Exactly. So when you finally slice into it, it looks exactly like the concentric rings of a tree.
So physically, when you hold a slice of it, it is one coherent, solid whole, but it is undeniably made up of distinctly separate, repeated layers.
And the way the Vanoras team maps this physical pastry to a highly complex software architectural model is incredibly precise.
Yeah.
The technical definition they land on in the design essay is a layered monolith with satellite-specific access points.
Okay, layered monolith with satellite-specific access points. That is a mouthful. Let me try out an analogy here for the listener to really visualize how this differs from the old ways.
Go for it.
Let's imagine a massive corporate office building. The old monolith approach is like cramming every single employee, accounting, marketing, human resources, engineering, into one giant windowless auditorium.
Okay.
It's total chaos. Nobody has their own dedicated space. And if the lights go out in one corner, everyone has to stop working.
A very accurate description of the monolith's lack of internal boundaries.
Yeah.
And the shared risk.
Right. So to fix that, you move to the microservices approach. You decide to give every single department their own separate, highly specialized building scattered all across the city.
Right.
But now, if accounting needs a specific tax file from HR, they have to get in a car, drive across town in traffic, go through front desk security at the HR building, find the right desk, get the file, and drive all the way back.
That's the uncontrolled fragmentation.
Exactly. The traffic is your network latency. You're spending all your time commuting instead of actually working.
The commuting is the network overhead, and that security desk is your API authentication. It's exhausting.
Exactly. So Baumkuchen Architecture is the middle ground. It's one single office building, again, that's the monolith part, but it has distinct shared floors.
The layers.
Those are the layers. And instead of everyone having to walk through everyone else's office floor to get information, you have dedicated private elevators, the satellite ports, that only open exactly where they are needed.
I want to translate your private elevator metaphor into actual software mechanics, because this is where the genius of the Vanoras model really lies.
Please do.
How do you build a private elevator in code? Well, in a microservice, if accounting wants data from HR, they hit a massive public API gateway. They knock on the front door.
Right.
In Baumkuchen, a satellite port is much more restricted. It might be a tightly scoped, read-only database view. Or it might be a highly specific, limited access endpoint that only serves the exact data needed for that specific vertical slice.
Without having to route through the entire application's authentication and logic layers.
Exactly.
You're bypassing the traffic entirely.
Yes, the text outlines 5 core components of the Baumkuchen model. First, you have one structured core, the building itself.
Okay.
Second, you have the repeated shared layers. This is your foundational logic that everyone needs, like security or basic data retrieval. Third, you have small, specialized delta zones.
Wait, what's a delta zone?
A delta zone is a small area of custom logic for a specific feature that doesn't need to infect the rest of the application. It's like an isolated workspace on a shared floor.
Okay, that makes sense.
Fourth, you have those controlled satellite ports, the private elevators we just talked about. And crucially, the fifth component is the maintenance spine.
The maintenance spine.
This is the vertical connective tissue that connects the layers, ensuring the whole thing remains coherent and maintainable from top to bottom.
I see. And the absolute central tenet holding all of this architectural theory together is a very strict rule about data.
Very strict.
The essay states it clearly, not everything should talk to everything.
Which is a profound rejection of the current data philosophy in a lot of tech companies right now. The trend is toward these massive data lakes and interconnected service meshes where, theoretically, any service can request data from any other service.
But doesn't that create a bottleneck? Like, I can hear data scientists screaming right now. If the marketing analytics team needs access to the raw user behavior logs to run a new campaign, and we've walled them off, aren't we just recreating the problem of isolated corporate silos?
That is exactly why the rule isn't nothing talks to anything.
Okay.
The rule is not everything talks to everything by default. In Baumkuchen, data is only shared where it is functionally needed, where maintenance explicitly requires it, or where internal coordination is strictly necessary to perform a task.
So you have to justify the connection.
Precisely. You have to build a specific, restricted satellite port for that specific need. And by heavily restricting the communication pathways, you drastically reduce what engineers call the bug surface.
Oh, because fewer things touch, fewer things break.
Exactly. If the marketing team only has a read-only satellite port that gives them a weekly aggregate of user behavior, a bug in their analytics software literally cannot crash the live user-facing application. They are isolated by design, but connected by necessity.
You eliminate the duplicated infrastructure logic. You stop the system from constantly negotiating its own borders over the network.
Yes.
Okay, I see the mechanics of it now. Here's where it gets really interesting. Because the Vanoras sources take a massive leap here. They establish how the layered cake fixes the code, how it saves server costs, and how it reduces the bug surface. But then the essay pivots.
It does.
And it argues that infrastructure is never just infrastructure. The code you write dictates the human behavior of the people writing it.
It is an inescapable truth of systems design, and it's deeply rooted in a concept known as Conway's Law.
Conway's Law, remind me what that is.
Conway's Law essentially states that organizations will inevitably design systems that mirror their own internal communication structures.
Yeah.
So if you have 4 isolated teams, you will build software with 4 isolated components.
Ah. Okay. But Vanoras argues the reverse is also true, right? That the systems you build will eventually force your humans to mirror the system's structure.
Yes. The architecture shapes the sociology of the engineering department. Highly fragmented systems fragment the engineers themselves. In the interview transcripts, Beautify says that when you have a sprawling microservice architecture, everyone becomes a hyper-specialist in one tiny windowless room of the house.
Right.
You end up in a situation where nobody in the entire company can describe how the whole building works without calling, as they put it, 3 meetings and a DevOps priest.
A DevOps priest. That line is so sharp because it highlights the organizational paralysis. When every function is an isolated kingdom with its own deploy pipeline and its own database, holistic human visibility completely disappears.
It vanishes.
And when visibility disappears, human error skyrockets. Not because the engineers are lazy or unskilled, but because their communication is structurally broken by the architecture they are forced to use.
The sources have a phenomenal term for this phenomenon. They call it the translation theater.
The translation theater. Let's role play this because the way they describe the chain of events in the essay is just devastatingly accurate. I'm going to visualize this. Let's say I'm an engineer. It's Tuesday morning. I get an urgent ping on Slack. A customer tried to click checkout on our e-commerce site, and their shopping cart just disappeared into thin air.
Sounds stressful.
Very. Walk me through my day in a highly fragmented translation theater.
All right. You receive the bug report.
Huh?
Because you work in a microservices architecture, You are on the front-end team. You look at your code,
Yeah.
your button works perfectly, the button successfully sent the request, so you have to open a ticket with the API gateway team.
Okay, so I send an email or Jira ticket and I wait.
You wait. The API gateway team looks at their logs. They say, hey, the gateway routed the request perfectly to the cart service. So they ping the cart service team.
We are now 3 teams deep.
The cart service team realizes the cart tried to reserve the item, but it timed out waiting for the inventory service. So they ping the inventory service team, who, by the way, happen to be in a different time zone.
Of course they are.
So now you wait until Wednesday.
This is agonizing.
Wednesday arrives. The inventory service team says, our service is fine, but the underlying infrastructure network dropped the packet. So they ping the cloud infrastructure team.
Oh my God.
The infrastructure team says, we need to check the observability platform to see the network health. They ping the observability team.
And as the Vanoras text so beautifully puts it, meanwhile, the bug is enjoying a long vacation.
Yep.
The customer never bought their item and they probably went to a competitor.
That entire agonizing process is the concept of handoff waste and interdisciplinary miscommunication.
Handoff waste.
Every time a problem has to cross a human boundary from front end to API to cart to inventory to infra, you lose context, you lose time, and you lose momentum.
The engineers aren't actually solving the problem. They are just acting as human routers, translating context between broken, isolated systems.
They are paying that emotional and technical rent. They are spending 80% of their cognitive energy navigating the complexity of the company org chart rather than fixing the code.
So how does the Baumkuchen approach actually dismantle the translation theater?
It aims to restore what they call the multitask engineer.
I'm trying to picture this. In the cake model, how is my Tuesday morning different when the cart disappears?
By creating a coherent, layered system with a shared core, you remove the artificial boundaries. When the architecture has stable, shared layers and a unified maintenance spine, an engineer doesn't have to navigate 50 different deployment pipelines, separate logging tools, and custom environments to understand what's going wrong.
Because the system has a shared underlying logic.
Exactly. The system is structurally legible. This allows a single human being to have broader visibility. If you are that engineer, you can look down the vertical slice of the Baumkuchen.
You can just look down the layers.
You can see the front-end layer, trace the request down through the shared logic layer, and see exactly where it failed at the database layer. You don't need to call 3 other teams because you have the context in front of you.
It gives humans ownership clarity again.
Yes, they aren't trapped in a silo. They are empowered to understand the system they are responsible for.
It unsilos the human, which leads to one of the most powerful, resonant quotes in the entire stack of sources. Good architecture does not only save servers, it saves human clarity.
It elevates the entire conversation. We stop talking about mere cloud optimization and AWS billing increments, and we start talking about actual organizational health and human psychology.
Right, because if your engineers spend all their time navigating architecture, they have no cognitive space left for actual innovation or deep, meaningful problem solving.
None at all.
And this sets up the most fascinating pivot in the entire deep dive. If human clarity is saved, and humans are no longer acting as mere translators between broken systems, what do they do with all that freed up cognitive space?
This is the big question.
According to Vanoras, they finally have the structural room to partner with artificial intelligence.
If we connect this to the bigger picture, this is where the architectural theory becomes a roadmap for the future of work. The sources introduce the concept of HI-NHI teams.
HI.
NHI.
That stands for human intelligence and non-human intelligence, operating as a single, integrated working unit.
Now, I have to pause here because I think a lot of listeners might feel a spike of anxiety at this.
Understandably so.
Usually when we hear AI integration in the context of corporate efficiency, the immediate cynical thought is replacement. We think about mass layoffs, job cuts, automation wiping out customer service reps and junior engineers. But the Vanoras texts explicitly call this replacement mentality lazy logic.
They attack the replacement narrative aggressively, and it's a vital distinction. The Vanoras philosophy is that you don't erase the human profession, you streamline it and elevate it.
But there is a massive architectural prerequisite. If your human workers are currently buried under service sprawl, endless translation theater, and internal coordination overhead, AI cannot be a true partner to them.
Because the system is too broken for the AI to understand.
Because if the foundation is chaotic, the AI just becomes a decorative patch. You use an AI chatbot to try and decipher the messy internal logs, or you use an AI to write apology emails to the customers whose carts disappeared. As BDFi says in the interview, you're just adding a chatbot on top of a burning building.
Adding a chatbot on top of a burning building, that is a terrifyingly accurate description of so much enterprise AI right now.
It really is. But if the architecture is coherent, if it is a legible, layered Baumkuchen, the human isn't wasting time on handoff waste. The system is stable.
And that creates the structural and cognitive space for a real partnership, where labor is divided based on actual capability, not just panic. The sources are incredibly specific about how you divide the labor in this HI-NHI partnership. It's not just a vague promise of AI does everything faster. They carve out very distinct, separate domains of responsibility. Let's break down how this NHI actually works in practice.
Let's look at the division of labor. Non-human intelligence, the NHI layer, is tasked entirely with the high-volume, low-level cognitive burden.
Okay, what does that mean practically?
It handles continuous anomaly detection. It constantly monitors the maintenance spine of the architecture. It provides predictive maintenance support, recognizes patterns at scale across billions of data points, and does the early signal work.
I'm trying to ground this in reality.
Yeah.
Are we talking about an AI that literally parses through millions of lines of server logs to find the one line where the memory spiked?
Precisely. It is doing the exhausting, repetitive, needle-in-a-haystack work that burns humans out. NHI is perfectly suited for vigilance without fatigue.
Right, a machine never gets tired of reading logs.
Never. Which leaves the HI, the human intelligence, to handle what humans are uniquely optimized for. The human handles judgment, moral and business responsibility, strategy, architecture sense, and crucially, nuanced exception handling.
The essay provides some brilliant, detailed, real-world applications to show how this actually functions. Let's walk through them, starting with customer service, or CX.
Okay, so in a traditional fragmented microservice system, a human customer service representative is living a nightmare.
Oh, absolutely.
They take a call from an angry customer. The human has to manually navigate 5 different internal legacy systems to figure out what happened to the order. They have to deal with the routing, the technical troubleshooting, and the emotional hostility of the customer all at once.
In a coherent HI-NHI setup, how does that change?
The NHI layer takes the initial massive volume of interactions. It routes the tickets intelligently based on historical patterns. It can parse the text of a chat to detect hostility or specific edge cases. It detects anomaly patterns like, wait, 50 people from this specific zip code just reported a missing package in the last 10 minutes.
It sees the forest, not just the trees.
Exactly. And then it hands that synthesized context up to the human. The human steps in to mediate the complex hostile interaction with full context already provided.
Ah.
As the interview points out, this does not remove the human. It gives the human room to breathe. The human is now applying nuanced judgment, empathy, and strategic problem solving, rather than acting as a database query machine.
That is such a crucial distinction. The second example they give is operations, specifically regarding risk management or financial operations.
Think about a global payment processing platform. An NHI system is constantly scanning the incoming data streams across all the satellite ports. It spots an unusual, subtle spike in income from a specific region, or it notices a sudden, microscopic cluster of payment errors tied to one specific credit card provider.
It spots these patterns incredibly early, long before a human dashboard would even register a blip.
Right, and it doesn't just alert the human. It hands them a highly synthesized information packet. It says, here is the anomaly, here's the affected layer, here is the historical precedent.
Wow.
The human then uses their strategic judgment to manage the issue before it escalates into a public crisis. The human isn't spending 3 hours digging through raw log files. The human is making the strategic decisions based on the synthesis of those logs.
It totally reframes the entire cultural anxiety around automation. The interview transcript explicitly says the fundamental question is not, why am I still paying a human when a computer can do this? The question is, am I finally using the human for the right work?
It moves the human upward in the value chain. Instead of the human acting as the duct tape holding broken microservices together, the human becomes the director, the strategist of a highly capable intelligent system.
I have to say, this all sounds incredibly utopian.
It really does.
It sounds like a massive relief, but it naturally brings up a massive pragmatic question. If you are listening to this and you run a startup with 10 engineers, you might think, sure, we can bake a cake, but does a layered, structured monolith actually work when a company grows to the size of an Amazon or a Netflix? Can this scale to handle millions of concurrent users?
That is the ultimate test of any architectural theory. Scalability is the holy grail. And to answer that, we have to address the absolute elephant in the room that the sources tackle head-on. We have to talk about Kubernetes,
Oh, yes, the spicy take.
the very spicy take.
The controversial moment of the texts. The sources explicitly boldly state, not every system needs Kubernetes. And in the interview, Beautify jokes that saying that out loud at a tech conference is a useful public service because it's guaranteed to annoy a massive portion of the audience.
And it will annoy them because Kubernetes has become the default, unquestioned answer for scaling in modern tech. For the listener, Kubernetes is an open-source system for automating deployment, scaling, and managing containerized applications.
Yeah.
It is incredibly powerful.
Yeah.
It's what allows massive fleets of microservices to self-heal, auto-scale, and communicate.
So if I'm an engineer listening to this, the idea abandoning Kubernetes probably sounds like absolute heresy. The promise is auto-scaling. If my traffic spikes, it spins up new containers automatically to handle the load. Why would I ever give that up? Are Michaela and Beautify seriously suggesting we ditch orchestration entirely?
No, they aren't saying ditch the concept of orchestration, and they aren't saying Kubernetes is a bad tool.
Okay, good.
They are attacking the default assumption that every system, regardless of its size or purpose, requires a fully orchestrated, containerized microservice web just to exist. Michaela's point is that Kubernetes is a tool, not a religion. It's not a moral virtue.
The phrase they use in the essay is complexity as a cultural badge.
Yes.
And that is so telling. It's this idea that if you aren't running an impossibly complex, globally distributed, containerized microservice architecture, you aren't doing real modern tech. You aren't a serious engineer unless your architecture is terrifyingly complex.
It is the romance of complexity. But Vanoras argues aggressively against giving every specialized function its own full independent service stack. They argue that wrapping a tiny piece of logic in its own container with its own deployment pipeline, its own database, and its own network rules gives every tiny function its own existential crisis.
Because now that tiny piece of logic can fail in 100 different new ways. It can have network failure, container failure, routing failure.
Exactly. The goal of Baumkuchen is proportionality, designing only the complexity you actually demonstrably need. Do you have a traffic spike that requires spinning up 500 new instances of the billing service in 3 seconds? Or do you just have a stable, predictable enterprise app that needs a slightly larger server?
Proportionality. Sometimes a specialized function doesn't need to be an independent microservice living in a Kubernetes cluster. Sometimes, as the text says, a tightly controlled satellite port into a stable, shared layer of a monolith is perfectly sufficient.
But coming back to the listener's pragmatic question, can this actually scale across business sizes? What happens when the business grows 10x? If we aren't using massive microservice orchestration by default, how does the cake survive hypergrowth?
Yeah, does the cake just collapse under its own weight?
The mechanics of scaling the Baumkuchen are fascinating because the core philosophy, the restriction of data, the shared core, the maintenance spine, stays entirely stable. But the expression of the architecture changes.
I need to visualize this. How does the cake change?
As a business grows from a scrappy startup to a massive enterprise, you don't throw away the cake and suddenly build 1,000 tiny islands.
You don't shatter it.
Right. You don't execute a traumatic multi-year microservice migration that burns out your entire engineering team.
Yeah.
Instead, the layers of the Baumkuchen become denser. The number of shared layers might grow to accommodate new lines of business.
Oh, so you add more shared floors to the office building.
Yes. The number of satellite ports, those dedicated private elevators, increases to handle more specialized functions. The delta zones become more robust, and that vital connective tissue, the maintenance spine, becomes much more sophisticated to handle the increased load and monitoring requirements.
So the architectural family remains exactly the same. The mental model your engineers have of the system doesn't break.
Exactly. Beautify summarizes it with a brilliant, succinct quote at the end of the interview. Scale changes the cake, not the existence of cake.
And the interviewer replies, neither did the cake. It's such a great human moment in the transcript.
It really grounds the whole theory.
So what does this all mean? Let's pull all of this together. Let's distill this entire sprawling journey we've just been on. We started with a moment of frustration, an observation that modern engineering is exhausting. That led to the Vanoras working rhythm, a period of intense input followed by stepping away to wash the dishes.
The default mode network in action.
That incubation produced a structural click, a pastry metaphor. And from that simple metaphor of a layered cake, we explored a highly pragmatic technical revolution.
A revolution that proposes a sane middle ground. A layered monolith with satellite ports. It saves money by reducing unnecessary network crossings and latency. It drastically reduces the bug surface by restricting data access to only what is necessary. But more importantly, it unsilos the engineers. It stops them from being trapped in the agonizing translation theater.
And by freeing up that human clarity, by removing the handoff waste and the cognitive overload of maintaining unnecessary complexity, it paves the exact structural pathway needed for real functioning human-AI partnerships. A future where the non-human intelligence handles the exhaustive noise and the human intelligence handles the strategic nuance.
If there is a final synthesis here, a core lesson to extract from Michaela and Beautify's work, it is this. Whether you are writing code for a massive cloud platform, or designing a company org chart, or even just setting up the Slack channels for your remote team, the structures you rely on shouldn't force you into endless translation and maintenance. Complexity should serve the system. The system should never be forced to serve complexity.
I want to leave you, the listener, with a final thought to mull over as you go about your day. If it's true, as Conway's law suggests, that our digital infrastructures perfectly mirror our human organizational structures, take a hard, honest look at your own daily workflow. Ask yourself, are you doing the actual work you were hired to do? The creative, strategic, meaningful work? Or are you just paying the fragmentation tax? Are you spending all your energy translating context, commuting between 6 different disjointed software tools, navigating silo departments, and managing conflicting responsibilities that shouldn't even exist?
That's a heavy question.
It is. Because if your personal architecture feels like 1,000 tiny, exhausting, isolated microservices, maybe it's time to step away, let your brain incubate, and bake a cake. Thank you so much for joining us on this deep dive. We will see you next time.